Meteorologist James Long here with Dynamic Weather Agency LLC. Good afternoon. This is December 15th, 2021, and we got a moderate risk for severe weather today. Now, taking a look at our severe weather threat for today, like we said, there's going to be a moderate risk for severe weather today, for severe thunderstorms this afternoon into early tonight, for extreme eastern Nebraska, across Iowa, into parts of southeastern Minnesota, and extreme southwestern Wisconsin today. You can see the enhanced risk and slight risk surrounding that, and that marginal risk extending all the way down to parts of northeastern Oklahoma, stretching into parts of eastern Kansas, all the way across portions of central and northwestern Missouri, western Illinois, all the way up through parts of Wisconsin, into the UP of Michigan today. Taking a look at that moderate risk again today, like we said, that's at level 4 out of 5 on our severe weather scale today. That moderate risk is going to include places like Omaha, Des Moines. We're talking about Fort Dodge, into the Waterloo area, Mason City, up towards Rochester and Red Wing. You can see surrounding that, there's that enhanced risk, including places like Lincoln, Nebraska, Sioux City, Cedar Rapids, and in that slight risk is going to include places like Minneapolis, all the way into Stevens Point and the Norfolk area in Nebraska, and many locations within that marginal risk, such as the Rockford area, Macomb, all the way up towards the Green Bay area in Wisconsin today. Now, taking a look at our categorical risks for today. First, taking a look at our tornado probability. Here we are taking a look at our tornado prob. We do have a 10% contour for tornadoes today, stretching all the way from that Omaha to Des Moines, all the way up towards that Rochester area, basically encompassing much of that moderate risk area today is where that greatest potential for tornadoes is going to be today. And you can see the 5% and 2% contour surrounding that in the cities and locations there that is going to impact today. That 10% contour is basically showing us where that greater instability and wind shear is going to be later on today, near that synoptic forcing of that triple point, close to where that is going to be as that low pressure system tracks to the northeast. And we'll get more into that here in just a little bit. Taking a look at our hail probability today is going to be rather low, around the 5% probability for today, stretching all the way from portions of eastern Nebraska through the central and eastern western portions of Iowa, and including that southeastern and western portions of Minnesota and Wisconsin today. Taking a look at our wind probability, this is going to be our other big player today. Strong, severe, damaging winds are going to be a pretty big factor today. 60 to 70 plus mile per hour damaging winds within that 45% and 30% contour area today is going to be where the greatest potential for some strong damaging wind gusts are going to be, all the way from basically that eastern portion of Nebraska all the way up into through much of Iowa into portions of Minnesota and Wisconsin today in that risk area. That's going to be the driving factor for basically much of that enhanced and moderate risk weather that we're expecting today across those areas. Now, taking a look at our surface chart, like we said, we got this area of low pressure that's going to be developing today across portions of Colorado, a warm front lifting northward across the region, and a deepening and more developing cold front that we'll see as we move into our forecasted charts here in a little bit, and a slight dry line extending across portions of eastern Nebraska through Kansas, western Oklahoma, and west Texas. As we take a look at our GO16 visible satellite imagery today, you can see across where our severe risk area is today. We are seeing a little bit of clearing across the area. This is going to help increase that instability across the area, along with some diurnal heating, helping bring some more increased temperatures across the area today. You can see that strong low-level jet moving across the area of those fastward south to northward moving clouds across the area, and that's helping evac some of that warm, moist air and instability back on over the region. Now, as we take a look at our forecasted surface charts, like we said, that area of low pressure that was over Colorado is going to continue to move off to the north and to the east today, continuing to deepen and develop due to upper level support across the area. We got a nice strong shortwave trough moving across the area, along with a jet max and very strong upper level diffluence that's going to help provide exhaust for this area of low pressure. That's going to help deepen those surface pressures at the surface. Like we said, you can see that more defined cold front as we go throughout the evening into the overnight hours, along with that warm front continuing to lift northward, bringing some of that moisture and that warm air back to the region. And here we are now at about 6Z, taking a look at about midnight Central Standard Time. You can see that well-defined cold front, that warm front now over parts of the northern Great Lakes region. Like we said, with that strong low-level jet across the area today and some of that southerly flow, we're seeing some of that moisture move on back into the area today. Dew points are going to be moving on into portions of the 60s, low 60s across the warm sector ahead of that frontal system. And that's going to be a really prime humid environment for the development of severe weather as that cold front interacts with that very humid air mass with those dew points in the low 60s across the area, maybe into the mid 50s as we get into portions of Wisconsin today and Minnesota. That'll be prime enough for the development of severe weather across the area, along with that synoptic forcing as that front continues to move on through. With that warm, moist air moving on in due to that low-level jet, we'll see the return of surface instability across the area. Surface instability isn't going to be as strong as we saw on December 10th and 11th with the major tornado outbreak that we saw across parts of the Tennessee, Kentucky, into portions of Missouri and Arkansas, where we saw some of those long track severe tornadoes the other day. Surface instability is going to be rather on the a little bit lower side as we take a look at this. Instability is going to be right around 1,000 to about 1,500 joules per kilogram of surface instability. And what we're meaning by surface instability is we're looking at here, the parameter is called CAPE, is convective available potential energy. It's basically the amount of buoyancy and the amount of kinetic potential energy stored in the atmosphere. Basically, any thunderstorms are able to develop in this environment have X amount of energy to feed off of. The stronger the energy there is, the stronger the updrafts of these thunderstorms are. And this is basically showing us that the environmental lapse rate is much greater than the moist lapse rate, and we have cold air aloft with warm air closer to the surface, creating some instability. And this is going to be enhanced by that diurnal heating due to the decreased cloud cover that we're seeing across the warm sector ahead of the frontal system. It is going to be enhanced by that low-level jet, bringing that warm, moist air across the area, along with the forcing from the front and the shortwave trough axis that we'll see move across the area. Another way that we can measure the instability across the area is taking a look at our lifted indice right here. This is basically taking a look at our parcel of air at 500 millibars and seeing how much more warmer that is to our environmental temperature right here. And basically we're seeing lifted indices anywhere from -4 to about -6, -7 across the warm sector, mostly going to be focused around where some of that greater surface instability CAPE was in western, basically Iowa into that eastern portion of Nebraska today is where that greatest surface instability is going to be near that triple point of that low pressure system that's going to be moving across the area. So basically we're seeing some moderate, mid-level instability, basically based off of our CAPE profiles that we'll see here in a little bit as we take a look at our SKUTs. Now taking a look at our energy helicity index right here, this is showing us where that best surface base instability is going to be, along with that best surface to 0 to 1 kilometer shear that's going to be needed for low level rotation for tornado genesis. And this is a great parameter to take a look at for areas where tornadoes may develop today. And basically that extreme eastern portions of Nebraska into basically western and central portions of Iowa, I think, are going to be the greatest potential players for tornadoes today. There is a small potential, I do believe, across portions of southern, basically Wisconsin, and that extreme southwestern portion of that southern portion of Minnesota and that extreme southwestern portion of Wisconsin today. But for the most part, I think most of that tornado potential today is going to be across that eastern portion of Nebraska, western portion of Iowa, and two portions of central Iowa today. And here's again, take a look at that energy helicity index. Like we said, best surface instability, best 0 to 1 kilometer wind shear, and is basically going to basically help us show where that best basically helicity is going to be moving on in and training into those thunderstorms. Now taking a look at our storm relative helicity right here, this is basically showing us the tendency for cyclonic rotating updrafts within the warm sector ahead of this cold frontal system. By the time we get into those oranger and more red values right there, that's when we're starting to hit above 300 meters square per second square. And basically, whenever we start getting above 300 meters square per second square, that's basically saying that we have the potential, a very strong chance for rotating updrafts and supercell thunderstorms, and even the potential for possibly some strong tornadoes to develop based off of statistical probabilities due to those values that we see right ahead of that cold front right there. And values are approaching anywhere from 350 to even 400, even 500 meters squared per second squared, just out ahead of this. Now, like we said, we do have a strong low-level jet moving across the area, that south to northward low-level jet that's evecting some of that warmer, more moist air from those lower latitudes up towards basically the Corn Belt region into the Midwest area, with that strong low-level jet of 30 to even 55 knots in some regions, screaming across the area. That's also going to help basically increase some of that storm relative helicity and the effective inflow layer into any of those supercell thunderstorms that we have across the area. Taking a look at 500 millibars, we have a major shortwave trough moving through the trough axis right there. We also, that's going to help enhance upward vertical motion in the mid-levels. We also have a little bit of diffluent flow in the mid-levels, so that's going to help create some exhaust at 500 millibars. You can see the trawl, or a trough of warm air aloft, that wave-induced trough, indicating that we have a mature system with this trough axis becoming more neutral to negatively tilted, and that's going to help increase the warm air advection, moist air advection, just out ahead of that. As we take a look at our 500 millibar vorticity, again, right ahead of that shortwave trough axis, we got a lot of PVA, positive vorticity advection, cyclonic spin within the atmosphere. And as we take a look at our 300 millibar chart, you can see that basically our PFJ moving across portions of Nebraska into basically Iowa and Missouri right there, and you can see the divergent, and based off of this we can determine that we have some good upper level divergence based off the quadrants of our jet max, along with that diffluent flow out ahead of that, helping increase that divergence aloft right there. We can see a little bit of our subtropical jet ridging across the area with that expansive ridge axis across portions of the Midwest and the Southeast, expanding all the way into parts of the New England territories and the Northeast area. Now, taking a look at our significant tornado parameter, like we said, as that low-level moisture and that instability increases across the area, so is that significant tornado parameter event right there. And you can see right here, based off of our significant tornado parameter, it looks like that eastern portion of Nebraska, western Iowa, into central Iowa, we'll see a great potential for tornadoes today, and that will stretch eventually into portions of southeastern basically Minnesota, into that southwestern portions of Wisconsin, as that low pressure system continues to track to the north and east, where that triple point is going to be, where we're going to have that greatest back to low level winds and that greatest directional wind shear near the surface. Taking a look at our forecast sounding right here, this is in western Iowa right here. Again, you can see we have a very moist low-level environment, temperature around 63, dew point around 62. That's going to help lower those LCL heights. Lower LCL heights, the better it is for tornado genesis, because the tornadoes don't have to extend very far from the cloud base to the surface. Taking a look at our Cape profile right there, our Cape is right around 1,300 to 1,400 joules per kilogram, like we showed on that satellite imagery. If we continue with that clearing right there and we get a lot of solar radiation at the surface, we could create a lot more mixing in the low levels of the atmosphere, increasing the low level lapse rates, potentially creating a more fatter Cape profile across the area, and that will help increase the instability across the area. Taking a look at our wind profile right here, our winds are coming from the south here at the surface, but just right above the surface, we're at about 55 to about 75 knots here at about 850 millibars. So a very strong low-level jet. Like we said, a low-level jet is definitely helping invect a lot of that warm, moist air back across the area, and it's going to definitely help increase some of the helicity values and our storm relative helicity as we take a look at our hodograph here in just a little bit. At 500 millibars, we're sitting at about 115 knots at our mid-level jet, and our 300 millibar jet is basically screaming overhead at about 130 to 135 knots in some areas. So a very strong jet max and some upper level divergence aloft that we have moving on over the region. Like we said, with that Cape, taking a look at our lifted indices, -5 to -6 across the area. And that's, again, taking a look at that parcel temperature here at about 500 millibars, comparing that to our environmental temperature right there. And that's what's given us our lifted indices of basically -5 to -6. So a moderately unstable environment right there based off our Cape profile. Taking a look at our hodograph right here, we do have a little bit of we do have a curved hodograph right here, and it becomes really elongated as we get past our basically 3 kilometers, so our 3 to 6 kilometers, due to that very strong mid to upper level jet movement across the area, with our hodograph basically just moving well off of our well off the charts right here. And with that photograph, taking a look at that elongation right there and our storm relative direction right here, our mean storm vector at about the northeast at about 60 to 70 miles per hour. So those are going to be some very strong storm motions, even storm motions approaching about 80 miles per hour. So they're going to be hard to keep up if you are chasing across the area. Like we said, storm motion will be at 218 degrees at about 79 knots. So really fast storm motions right there. And taking a look again right here, taking a look at our shear surface to 1 kilometer sitting at about 52 knots, surface to 3 kilometer 58, and our surface to 6 kilometer is at about 96, so almost about 100 knots at our surface to 6 kilometer shear. Typically, for surface to 3, surface to 6 kilometer shear, I like to look for about 35 knots, and we're nearly double or greater than double than that, depending on which parameter you're looking at there, surface to 3 to surface to 6 kilometer effective bulk shear. Like we said, taking a look at our effective layer, significant tornado parameter right here, we're looking at about a 4. And so we take a look at the box and whisker plots right here, the mean right here for EF3 tornadoes, we're sitting well above that right there. We're sitting at normally at some of our max for our mean box and whisker plot values right there, and we're even getting into some of the values right here for EF4 plus. So definitely the potential for some strong, significant, even the violent tornadoes. But for the most part, I think most of our tornadoes are going to be right around the EF1 to EF2 range today. Maybe one isolated EF3, but given the very strong shear and the weaker instability that we have this time compared to our December 11th and December 10th and 11th outbreak that we saw, there's a potential for some of these storms to be sheared sheared a little bit. So that's a slight concern. But right now the forecast soundings or some of the forecast models like the Futurecast radar isn't really suggesting shearing of the thunderstorms, but it's something definitely to be considerate of. But I do see definitely a good potential here for tornadoes given the wind shear and the synoptic forcing that we have within the atmosphere, even given the low CAPE values, because our photographs are just very impressive by the shape and the look of them.